We can now look at integral calculus, and this is the reverse of differential calculus. Studies the accumulation of quantities, e.g. linear distance traveled, area under a curve, volume displaced, etc. Similar image of differential calculus. And it's an integral. An integral is an anti-derivative, i.e. the reverse of a derivative. Recall that if y equals ax to power n, then dy dx equals nax to power n minus 1. We've multiplied by the power and we've stepped down the power. We have reduced the power by 1, we have multiplied by the power. Now, the antiderivative is we do the reverse of what we did in differential derivatives. The antiderivative is nax to power n minus 1 plus 1 over n minus 1 plus 1 equals axn plus k, where k is a constant of integration. The constant may be any symbol different from the variables in the question. It can be c, k, m, a, alpha, etc. Find the integral or antiderivative of dy dx equals 2x. Now y equals 2x squared, so 2x to power 1. Now when we are finding the integral, then we divide, we add 1 to the power, i.e. we step up the power by 1, then we divide by that new power. So 2x to power 1, when we step up the power by 1, it becomes 2x squared. Then we divide by the new power 2, i.e. plus c, and this will be x squared plus k, where k is the constant. Integrate, this symbol long s is summation of a continuous variable, and it is instructing you to find the antiderivative of. So integrate 6 squared minus 3x squared plus 10 minus integrate 6x cubed minus 3x squared plus 10x plus 8 with respect to x. So the first term is 6x cubed, so now it becomes 6x to power 4 divided by 4, then minus the second term, which is 3x squared. When you integrate it, it becomes, increase the power from 2 to 3, so it becomes 3x squared divided by 3, then minus 10, integrate 10x, so it will be 10x squared divided by 2, then plus 8x to power 1 divided by 1 plus k equals 3 over 2x to the power 4 minus x cubed plus 5x squared minus 8x plus k, the constant. Integrate 12x squared, integrate 12x cubed plus 3x squared minus 2x plus 10 with respect to x will become 3x to the 4 plus x to the 3 minus x squared plus 10x plus k. Then evaluating an integral. Here, the integrals we have looked at above are infinite integrals. They have no limit. That's why you have constant k. And the constant k might be 1,000,000, might be 20 million, might be very large, or might be very small, negative 50, etc. Now, want to deal with a constant, so that we deal with a definite integral. This one has the lower limit and the upper limit. E.g., this is telling us to integrate this function from 1 to 2. We are accumulating from 1 to 2. Integrate 2x plus 3 with respect to x. It will become x squared plus 3x from 1 to 2 outside the brackets, and this will be so we substitute for x with these values, the upper limit values minus the lower limit values. This will be 2x 2 to power 2 plus 3 times 2 minus 1 squared plus 3 minus 1 plus 3 times 1, and this will be 10 minus 4 equals 6. We have evaluated an integral. Now I want to deal with the differential equations. These are equations with derivative terms, i.e. of the form dy dx. Solve the equation dy dx equals 2x. We integrate both sides with respect to x, and the left hand side becomes dy, so it becomes y. Then the left hand side is 2x squared over 2 plus k, i.e. x squared plus k. That is the anti-derivative. We can solve more equations, e.g. x minus dy dx equals 3 dy dx plus 6. Look at like terms. We add to both sides 3 dy dx, and we subtract from both sides x. So we shall have 2 dy dx equals 6 minus x. So dy dx then equals, we divide both sides by a half, or we multiply both sides, we divide both sides by 2, so dy dx equals 3 minus a half x. And we integrate both sides with respect to x. We have 3x minus a quarter x squared plus k. This is a general solution. Now, if we are given values for x equals 2, y equals 15, or at a point where x equals 2, y equals 15, we can find the value of k, such that y, i.e. 15, equals 3 times 4 minus a quarter times 4x squared, k equals 7. So y equals 3x minus a quarter x squared plus 7. This is a particular solution. I want to look at a business illustration. Stereo Limited manufactures discs. The cost accountant has discovered that the marginal cost of producing discs is given by C prime equals 4Q plus 50, and the marginal revenue is R prime equals 200 minus 6Q, where Q is the level of output, i.e. the number of discs produced. Derive the function for revenue, derive the revenue function, given that the the sales revenue from 10 discs equals 1,800, i.e. derive the function for the revenue, derive the function for revenue if you are given that sales from 10 discs is 1,800. That's A. B, derive the cost function in this company given that the total cost of producing 10 discs is 850, sorry. Establish the maximum profit. Find the level at which the firm breaks even. Find the price at the profit maximizing level. That's an illustration. That's a problem we want to solve. Solution. MR, or marginal revenue, equals the R at the X equals the R at the Q. So the marginal revenue equals the R at the X equals 200 minus 6x. This implies that revenue is equal to integral of 200 minus 6x dx equals 200x minus 3x squared plus k. But this is a general solution. And we have been told that for x equals 10, R equals 1,800. Therefore, 1,800 is equal to 200 times 10. We substitute for x. Minus 310 squared plus k. So k is 100. Therefore, the revenue function is R equals 200x minus 3x squared plus 100. And this is a particular solution. B, we are supposed to derive a cost function, but marginal cost, the C dx is equal to 4x plus 50, as we have been given. Now C is equal to the integral of the right hand side for x plus 50, which is equal to 2x squared plus 50x plus k. But this is a general solution. We have been told that when 10 units are produced, the cost is 850. And therefore, we substitute for C and x in the above equation, and it becomes C equals 2x squared plus 50. Sorry, C equals 2x squared plus 50x plus 50 equals, plus 150. We substitute 10 in the equation for C, so, and 850 for C. 850 equals 210 squared plus 50, 10 times 10 plus k. So k equals 150, and therefore C equals 2x squared plus 50 plus 150, and this is a particular solution. Profit, break-even, and price. Now, profit is R minus C. So we subtract the cost function from the revenue function, and therefore pi equals negative 5x squared plus 150x minus 50. We differentiate it, it becomes negative 10x plus 50. Now, we equate the derivative with 0 because we know that at the maximum profit, the pi dx equals 0. This implies that x equals 15. We do the second derivative test, the 2 pi dx squared, to find what type of turning point it is at x equals 15. And this gives us the second derivative as negative 10, which is less than 0, and meaning that there is a maximum point at x equals 15. Profit, therefore, is maximized by producing 10 discs. Break-even is simply where R equals C. Total revenue equals total cost, i.e. profit equals 0. So you equate the profit function to 0, and 5x squared plus 150x minus 50 equals 0. So if you divide through by negative 5, x squared minus 30 plus 10 equals 0. This is all the form ax squared plus bx plus c, and we can solve it using that formula. Thus, x will give 29.66 or 0.34. Break-even is attained by producing 30 units, 30 discs. Price P equals average revenue, i.e. total revenue divided by x, number of units produced, which is 200 minus 3x squared divided by x, and this is 200 minus 3x, which will be 200 minus 3 times 15. So the answer is 155. And bye-bye.